Hello, good afternoon. My name is Antonín Lupíšek. I'm from the Czech Technical University in Prague. I'm Director for Research and Innovation at the University Center for Energy Efficient Buildings. Today, I would like to show you results of our study on the potential for a reduction of carbon dioxide emissions of Czechia by renovating of the national building stock. The background is quite clear, I guess, at this conference. So just to wrap up, 1/3 of the emission of greenhouse gases in the European Union comes from buildings. At the same moment, our sector of buildings have the highest potential for delivering significant and cost-effective reduction of greenhouse gases. We have the technologies, we know the way, we only need to make it happen. At the same moment, we thought that it would be nice if our country have estimation how the building stock could contribute to our climate mitigation goals. So that was the motivation, and the objective of our study was to contribute to our national discussion and to review the renovation option of existing building stock, define the renovation scenarios, quantify the potential of CO2 savings of each scenario towards 2050. And we also wanted to consider the potential impacts of future reduction of emission factors and of cleaning of the electricity system and so on. And we also wanted to prepare a number for discussion at the national level for the potential share of the building stock on the national greenhouse gases emissions altogether. The work was being done in past years in a couple of national projects, and it is also aligned to IEA Annex 72 on carbon footprint of buildings and carbon benchmarks for buildings. And in order to deliver what we wanted to arrive to our goals, we first need to make an inventory of the Czech building stock, then the model its energy consumption, then define the scenarios, then define the energy sources and the shares, and estimate the future path and uptake of building integration and building attached PV systems. Then we model the energy consumption of residential and non-residential stocks. After that, we identified CO2 emission factors, quantify the potential for saving for each of the scenarios, and after that, we conducted a sensitivity analysis that would reflect the future changes in emission factors. And at the end, we make kind of evaluation how buildings can contribute to the national greenhouse gases savings. The inventory of the Czech building stock was based on statistical data. We had data from Czech Statistical Office. They had also focused a survey in 2018, which was focused on building stock. We got survey on energy carriers used in buildings in Energo 2015 census. And we also used the data from the National Registry of Energy Certificates and Energy Audits, which was provided by the Czech Ministry of Industry and Trade. And we had also data from the associations that are focusing on energy efficiency in buildings, associations of producers of thermal insulation and so on. We used data from them to estimate how big proportion of the building stock is already renovated and what is the renovation rate, because we don't have an official number like at the government level. For the modeling, we divided the stock into residential and non-residential, and we have used a stochastic model of 1,000 single-family houses and multi-family houses for the residential building stock. So it was a dynamic simulation in variance, which was adopted to be representative for the building stock, for the numbers that came from the statistics. And for the non-residential building stock, we have real models of 100 representative buildings of different types and shapes and uses. And we have real models that were used for energy audits. So there are real data on consumption and on the options for renovations. So we have used these models and we have extrapolated the outcomes of these models to the building stock per square meters, like in energy-wise. And we calibrated to results from the data from energy audits and from the national inventories of energy consumptions. After that, we defined 4 scenarios. The first was baseline scenario, which corresponds to the state-of-the-art policy, or it was like in 2016-17 when we started this research. So that was the baseline. Our baseline year was 2016, in fact, already. Then we have the scenario that was then defined by the Ministry and Industry of the Industry and Trade, which is responsible for energy energy agenda of the Czech Republic, because we had the feeling that this scenario is not ambitious enough. So that's why we included there to be able to compare it with other 2 scenarios. One was the progressive one, which was like modeling progressive deep energy retrofitting of the building stock, and we have even the hypothetical scenario, which was even faster. And I will show you the shares that were considered. So basically, this is each of the rectangles is 100 of the Czech building stock. On the left is the base year 2016. At the end is on the right is 2050, and this is modeling of different levels of renovation rates. So basically, the gray part is the non-renovated building stock. The orange is shallowly renovated, which is really the basic renovation as it goes, no special energy requirements. Then we have moderately renovated floor area, which corresponds to around 50 to energy demand around 50 kilowatt hours per square meter, and then the deeply renovated floor area, which is at the level of passive house, like 15 square meters, which means you would need extensive thermal insulation, triple glazed windows typically, and mechanical HVAC system with heat recovery. We have created the path of the transition between the energy carriers. So you can see the starting point, which comes from statistic for 2016, and then we defined various ambitious levels for each scenario. I will then show you the link to the paper when it's described more in detail. We have considered yearly amounts of electricity production from the building photovoltaics. We collaborated with the Association of Photovoltaic Systems of the Czech Republic, and they provided us their models and predictions how it could develop with the building attached and building integrated photovoltaics, and we used their scenarios to apply them to our models. Then we identified the emission factors. Some of them are quite crude numbers, not really precise, but the precision of the whole estimation is somehow limited. So we went it with them, and then we make the sensitivity analysis to be able to say how much it is sensitive to variation in future changes. You can see that electricity from the national grid is quite dirty still. A couple of years ago, the numbers were much higher. Now we are shutting down brown coal power plants, so it's going down. So the official number in 2019, when doing this simulation, was 0.6. Nowadays, it's like 0.48, and it goes steadily down, but it's still second or third dirtiest energy grid in the European Union. For the variance scenarios, for the sensitivity analysis, we have just used 2/3 and 1/3 of the electricity emission factor. We also somehow were looking into the reduction of emission factor on district heating system, because the renewables are being more and more applied in district heatings. And we also worked with some syngas option or biogas options that could be filled into the gas distribution system. So we also modeled some reduction of the emission factor of the natural gas nowadays. So after we calculated, we evaluate the potential share of building stock of national greenhouse gas emissions. This was our starting point, because the goal, which is not much ambitious at all, but it's some goal that was written in our legislation, is 80% reduction compared to 1990. So it's our national target for whole country is some 33 megatons of CO2. To put it in perspective, in 2016 it was 106. So when we make the calculations and modeling of the Czech building stock, we came up with the figure about 37 megatons of CO2, which was about 35% of the national emission. So basically, if we have the buildings as we have now, and we would like to reduce the national emissions by 80%, we should need to switch everything else except buildings, which is of course not the case. So we set some virtual target for buildings. So we calculated with equal contraction of the sectors. So we took the 34.6% share, multiplied it by the national target, and we arrived to 11.4 megatons, which is the emission goal, quite soft, but still goal for the building stock. And we are looking if we can achieve that. 1 minute. Okay, so I will speed up. So results, the residential and non-residential building stock, but I will show you in a chart better. So the full lines represents the whole building stock in the scenarios. The red line is the 80% goal, and you can see that the governmental scenario would not be reaching that goal. The other two would be possible to arrive at the progressive and hypothetical. And if we look at the numbers, as I mentioned, the goal was 11.4 megatons. And if we look into future changes in the emission factors as well, so we can go reduce it to 3.5, but it's still not zero, at least for what we have. There are a lot of uncertainties, emission factors, future development of shares of energy sources, development of building stock, and the patterns of energy consumption in buildings, and climate change. And we left out the embodied emissions at all. So this is another story. So I'm arriving to conclusion. If the national commitment is to be achieved, we need to apply at least the progressive scenario, which means that we need to speed up the renovation rates to 3% per year until 2025, and go to the passive house level for the most of the new renovations. And if we combine the decarbonization of building stock, like in the operation measure, is almost possible, but it would need a bold actions and of course the high investments and support from the state. So that's all. Thank you. Yeah, thank you. There is a link to the paper, there are details described. And I would like to invite you to Prague in July. We have a conference, we have 200 abstracts, and we will be discussing sustainable building. Thank you. Thank you very much. Thank you. You have yours? Thanks. Oh, you want to put it?
Yeah, it's sure that with an emission factor of 0.6 in Czech Republic, it will be difficult to reach those targets. Yes, which one is it? Yes, makes sense. This one. Okay. I will just share the screen and then I will let you go on stage. Yeah. Yeah. Thaleia, here you are. Oops, sorry.
So hello, well, to the people here and to the people watching us online. So today I'm going to talk about renovation process challenges and barriers, which is a study that we did within the framework of the NCRA project, which the project has the purpose of renovation, accelerating deep renovation. So we go to the next slide. Yes, there you go. So again, like here, we have almost the identical data that we saw before. So bottom line is well, building sector uses a lot of energy, and we need, in order to reach the climate goal, to increase both the rate and the depth of renovation, going towards deep to zero renovation, and that's okay, thank you. And that's a graph showing that, but I think we just heard how this is true from the Czech Republic, and the image in Europe is similar. So basically what we should keep from that is that we need to go to deep towards zero energy renovation, which means that we need to integrate a lot of components. And this means that the complexity of those renovations increases. And industrialization is a way to do that. Apart from being able to combine a lot of components in one solution, we also have the chance to improve the productivity, which makes upscaling possible, reduce the cost to economy of scales, reduce on-site construction time, have design and engineering efficiency, also reduce construction and waste. Construction waste and material use. So there is a lot of potential. That's why it's part of our objectives in this project. However, industrialized renovation have a lot of challenges. We heard yesterday in the workshop in this conference some of those. And so there are a lot of studies. This is also one study discussing those challenges. And we see that a lot of them are technical because of the complexity, but they're also linked to financial, but also barriers related with stakeholders and information, awareness, having good estimation of the benefits, and so on. So in order to help this process and overcome these barriers, the objective of this study, which is part of which was done within the framework of the NCRA project, is to map the renovation process and address the most important bottlenecks in order to make the renovation process more efficient, and identify specifically the type of information that the stakeholders require in the different phases of the renovation, as in an effort to structure the workflow between those actors and make it more efficient in terms of time, but also in terms of cost. The method to do that was, first, we had an exploration of state-of-the-art projects. We looked at 17 research and innovation EU projects, and to identify the type of target users, the type of information, and so on. And then, based on this information, we focused on expert interaction, focusing particularly in the consortium of this project, with an online questionnaire that was used for initial data gathering, and then some structured stakeholder workshops. The sample of that questionnaire was as follows. There were 42 questionnaires, and we see that we have a range of expert and type of disciplines. And there we can identify, let's say, the stakeholder roles, because it's one thing, like we have the type of business, where if it's architect or building engineer and so on, but it's more like what would be the role in this project. And it's we can see the design team. We have also a lot of people from the construction team, energy, services. We see that the client team, which means the user or the building owner, is relatively underrepresented in this in this questionnaire. And the reason for that is because we were focusing on the experts really doing and organizing the construction and the design process. So the results, I'm going to talk on those 4 main issues, which is about identifying the phases, and then the role of the stakeholder in every phase, and then the information flow and the main bottlenecks, because this is the basis to proceed later to give solution and make this process more efficient. In the renovation phases, of course, we can see in different publications and different reports, different ways of organizing that. But in general, we can see them as having the pre-project that defines the scope. And this is also where the building diagnostics are happening, or initial cost estimations, some initial scenarios are happening, and ends up in a way with the specification for the project and the design team. Then we have the pre-construction, which to the graph to the next is both phase 2 and 3, which is the concept design and the final design. And then we have the construction of the manufacturing, assembly of an on-site and so on. And this phase ends with the handover of the project. And then we have in the end the post-construction phase 5 in this graph. That is actually the operation of the building and includes tasks like monitoring, maintenance, and optimization of the operation. And if we combine those phases and then look which stakeholders are more involved, we can see that the design team has a strong involvement. And design team we can conceive as architects and engineering consultants. And they start from phase 1. Sometimes in phase 1, they don't even have the assignment yet to do the project, but they are involved in the discussion. And they go all the way until the handover of the project. The construction team, which includes contractors, system suppliers, energy solution providers, and so on. It's mostly it starts in phase 3, and it's mostly in phase 4 in the actual manufacturing of the solution. And the client team, which includes users, developers, or investors, and building owners, is there in phase 1, and they're most often they are the ones initiating the project, and they come back in phase 5 as having a very strong role, because in the phases in between is where the solution is being developed. Regarding the type of inputs, moving a bit to the information flow in this project. So here we see the type of input per phase. Well, I give a moment, maybe you want to read through those, but I think maybe I can group them a little bit, and you will have the chance to look into more detail in the paper. But we can see in the first 2 phases the information about the actual building, drawings, pictures, description of the services, properties on the envelope are very important. And we can see they're both important in the first phase, where we do building diagnostics and so on, but also in the second phase, where we actually have to start designing the intervention. And when we're moving towards the end, the later phases, we see that data about monitoring and energy consumption, and data occupants questionnaire about comfort and function and so on are becoming very important in the final phase, where the building operates. The cost is highlighted those. It becomes very relevant. It's always relevant from phase 1, but it really sticks out in phase 3 and 4, where it's really where we involve the suppliers, and they have to give the tenders and the final products, and order those products and install them. So that's another expression of the graph we showed before. So the darker colors are where those type of inputs are more mentioned during the questionnaires, and basically described at the beginning. It also shows the importance of the information of the existing building as input in terms of information. So going to the outputs in the sense of what kind of results or what kind of information the communication during the design needs to have. We see a lot at the beginning. We want to see a lot about design scenarios, and also indication about energy demand and energy consumption. And we see both in phase 1 and 2. And I think that's important, because we can see that those phases, even though they are distinct by when, for example, the commission starts for the project, they very much merge in terms of the type of information that we want during this discussion. And then moving towards the other phases, we can see in phase 4, which is the manufacturing, that we need a lot of details about the product, installation guidelines, logistics and planning guidelines. So these are the type of information that they're needed, and that they are also, they can be seen as the result of the communication of the stakeholders. And here I highlighted the cost again, because we see it again popping out more in the tendering phase. And that's again the same expression of those, the type of output that we can see in this communication. And I mean, here we talk in terms of input and output, because this is the basis work for making a communication platform to support the process, but we can also see it as information flow, what information we need and what information the stakeholders need to give back as results. Then moving to the mainly perceived bottlenecks per renovation phase. So that was a little bit more difficult. It was not a quantitative analysis, because it was an open-ended question. So this is a word cloud based on the answers. And then we can see that the design, it's not a bottleneck, but the design process, it's delayed. We see construction, partners, information. These are big words here. But in order to try to quantify this discussion of the bottlenecks, we counted the mentions of the different bottlenecks as coding them, like grouping them together. And here we see a lot is about the lack of information, unclear definitions, normative compliance, coordination and communication, responsibilities and guarantees, technical challenges, and those are not really surprising in a way. So we can see this in the other studies as well. I think what is here interesting to take away is that the main identified bottlenecks, the more prominent that have been mentioned a lot, really have to do with the lack of information and the coordination and communication. Yes, it's a couple of slides more. And this is an overview which I'm not going to read, but again, I wanted to show this is the type of bottlenecks per phase. And then we see that lack of information and communication and coordination have bottlenecks throughout the phases. So yes, and that's I think the main takeaways from this part regarding the bottlenecks. And really keep in mind that the type of information they need to exchange is important, and also how coordination and communication between the stakeholders. So to conclude, it's important in order to the common goal that I think a lot of people here have is to increase the rate of renovation and make the process more efficient. And to this end, the stakeholder communication and information exchange need to improve. And understanding this process and which parties need to communicate about what and when is crucial. And that's the purpose of the study and the results presented before. And based on that, we have some recommendations and some conclusions that we also take for our project to develop further. So we identified that it's important to give some archetypes in order to be able to provide renovation scenarios and cost indications at the early stage with minimum effort. The building data are very important, and they're used throughout the process in different phases, and we need a different level of details. So it's very important to have a comprehensive checklist of what we need, of the data we need to collect regarding the building. Technical information about the product from the manufacturers are important, and to this end, the construction suppliers is good to be involved earlier in the stage and not only towards the tendering, when the solution is already developed. And it's important to define clear responsibilities for the stakeholders, and also define communication channels and protocols for the communication of the design team, also with everyone, of course, but particularly also with the client team, because in the end, it's for them to approve the solutions and changes. So thank you very much.
You touch so many different takeouts that I very liked it. It's in one presentation you were able to explain like, all the process from like. No, it's the. I don't know. I'm curious to read the paper because like I saw that, for example, the life cycle assessment wasn't taken into account too much during the data exchange in any of the phases, and so I don't know if it's because there was lack of information in all those projects or whatever.
The project does have a component about life cycle assessment, so it is there, but it was not. It's true that it was not the most prominent, the type of information that they want, but it's part of the assessment and benefits of the solutions.
Yeah.
It's part of the assessment.
Yeah, I can imagine.
And this information is also part of the first public report of the project, which is also possible to read in quite some detail.
Thank you very much. Thank you very much. Yes, wait. I will. ¿Cómo se hace? Ya que no me acuerdo.
I can also do it later.
Okay.
Okay, perfect.
Solo tenemos que cerrarlo todo y ya está.
¿Sí?
Sí.
Okay. Okay, thank you very much, Thaleia, once again. And now, without further delays, we let Laura, if you can share your screen, there is a button on the bottom of the page with the cross line, red line, perfect.
Okay, I think you can see the screen.
Yeah, not in the presentation mode, but now you will put it. Okay, perfect. Thank you very much.
Okay.
Try to repeat it about 30 minutes if you can. Thank you very much.
Okay, thank you. Okay, good afternoon to everyone. It's a pleasure for me to be here. I'm Laura Vandi, Project Manager of Innovation for Focchi Group, and today I'm going to present you the prefabricated plug-and-play facade unitized for deep retrofitting. In particular, I'm going to talk about the RenoZEB case of study. Just to briefly introduce you in the presentation, I will give you an outline regarding what I'm going to talk about, just some general information regarding the RenoZEB European project. I will talk about the boundary condition of the existing building facade, and in particular, the development of the plug-and-play facade that we have developed in this project. And then I will show you the test conducted and the result achieved within the project. Just to give you an introduction of the project, RenoZEB is a European project which has started in 2017, and actually it finishes today. The project involves 18 different European partners, and the project coordinator is Michele Vavallo from Solintel. In particular, Focchi is an Italian company which design, engineer, manufacture, and install curtain wall facade. And in this project, RenoZEB was responsible for the development of the plug-and-play facade. RenoZEB aim is to establish a systematic methodology for the energy retrofitting for building stock market, and to achieve it, this purpose, the RenoZEB project developed a BIM-based platform and tool for actors and value chain. In the slide, you can see the four main pillars, which are common, which in particular, there are the reduction of energy consumption, the reduction in cost, and the risk for the retrofitting intervention. Our important thing is the replicability and the adaptability of the methodology, and as well as increase the property value. As a starting point, we have considered the boundary condition for the development of the plug-and-play facade. The plug-and-play facade is a crucial element in this project because it is the enabler of the methodology, but for its development, we started by analyzing the existing boundary condition for the facade. The key element to take in consideration are the structural part and the opening. The methodology want to provide a solution with a low intrusiveness. So we needed to keep as it was the facade configuration. So we started by analyzing and designing the facade module with the window, which has to be fixed, and then the secondary module, which are the module between the two different window opening. An important product and the development of the facade was the catalog, because the plug-and-play facade within the RenoZEB project is referring to standard of curtain wall facade, and the project offers a series of unit typologies as well as different cladding materials. But let's talk about the development in itself of the Focchi facade system. The concept is component by 3 different layers, and we saw the existing wall is the first layer, which has to be maintained as it is. The second layer is the cavity, which has a crucial importance because the cavity hosts the bracket system. In the bracket system, the RenoZEB prefabricated panel is hung through the existing wall. And the third layer is the RenoZEB prefabricated panel in itself. Here in this slide, you can see the technical drawing of the preliminary facade system. As I said, the RenoZEB plug-and-play is referring to a curtain wall facade. So we started by analyzing and using the materials of a standard curtain wall facade, but an innovative solution that we use also for fulfilling the requirement of breathability, we introduce an alternative solution, which is the introduction of a membrane. So we have replaced the metal sheet that is usually used as a tightness of the insulated panel with a membrane. So we can see an internal membrane has a vapor barrier, the insulated panel, and the external membrane has a which guarantees the waterproofness. Has a cladding system. The cladding system, so the external cladding system, is directly in contact with the external membrane. This is the second solution that we have developed. But what are the main differences between the first and the second solution? Mainly are 2. The first one is the introduction of a ventilated cavity between the external membrane and the cladding system. And the second one, we wanted to avoid as much as possible the use of structural sealant, because we wanted to keep in consideration also the disassembling phase of the plug-and-play facade. So in this configuration, we could guarantee the breathability through the ventilated cavity, and the structural silicone has been changed with a mechanical strength. Has been conducted also the glazed test for the condensation. In both the demo cases that RenoZEB has in Durango, in particular Durango and Boru, the simulation has been validated, so no condensation will be present inside the RenoZEB facade. This is the Boru demo case. The previous one was the case of Durango. And here you can see the final solution of our RenoZEB facade. As I said, there is the existing wall, the detail of the bracket, which is fixed to the existing wall, and the prefabricated RenoZEB panel is the RenoZEB panel hangs within the bracket. But the technical drawing is spread into different unit typology. So we have set a catalog as we have seen in the previous slide. In particular, there is the opaque unit, which is completely a spandrel part. And you can see in the right part of the slide the U-value transmittance that we have simulated and tested with this configuration. An important feature is the customization. So this solution could offer to our customers the possibility and the opportunity to choose the material that they want to have in their building. Some example is the cement board panel, the wood, fiber cement, or also porcelain tile. And here there are just some example of color and finishing for the build to meet all the aesthetical requirement. Here you can see the window module, which has integrated in itself the monoblock technologies and the roller shutter. Also, we have integrated several sensors and mechanical ventilation in order to monitor the indoor comfort. Again, another typology, which is the solar thermal collector unit. In the cladding system, we have integrated a solar panel as well as a photovoltaic panel. Here you can see some pictures regarding the manufacturing process in our facilities. There is the external frame filled by insulated materials, the membrane, which I explained in the previous slide, and the cladding materials with the mechanical restraint. Some other detail regarding the assembling part. Our prototype team, which is assembling the cladding panel. And here some pictures regarding the facade module. We have the opaque unit, the window one, the photovoltaic, as well as the solar collector unit. An important feature is the installation phase. Here we have simulated an existing facade in our facility. And you can see here all the phases, the bracket installation, the raising of the unit, and here the final solution. We have tried to, in one single visual mockup, we have tried to use different cladding just to show the result. And here the concept: existing wall, cavity filled by insulated panel, and the RenoZEB panel. I'm going to discuss about the testing that we have conducted. In the slide are listed all the tests which has investigated the thermal, the acoustic, and the fire behavior of this system facade solution. Let's start with the acoustic mockup. There is the technical drawing of the tested mockup. The test has been conducted here in our acoustic chamber by a third entity called the Istituto Giordano. We have developed 3 different configurations. The first one referring to a brick wall, which has been taken as a benchmark. Some result, we are really satisfied about the result, because we have seen an improvement of the acoustic behavior in comparison to a normal brick wall. And then this is the performance mockup. The design and the impact test. You can see in this picture there is the impact test and the pressure test. Also in this case, we are satisfied regarding the test because we fulfill all the requirements of the curtain wall standards. And at the end, also the fire mockup was a success, because we have tried 3 different configurations for the fire mockup. We tried the part which were in direct contact with the air, so the external cladding, the cavity, the ventilated cavity, and the cavity between the existing wall and the prefabricated panel. Some pictures regarding the testing we did in a middle furnace, and the results are really good. Just some consideration: a further implementation can be done by choosing not a plastic membrane, but if you want to reach an higher fire reaction, we can use an aluminum-based membrane. And here the most important test that we have conducted is the cubic. Has been installed 6 facade unit in the real living lab of a cubic, which is set in Tecnalian, made in Spain. And it was really important for understanding the installation phase, but also to test all the thermal behavior and the indoor comfort tested in a real environment before installing the facade in the demos building. So in conclusion, we can say that the plug-and-play facade is a valuable technology solution for a building envelope deep retrofitting. It's important because it's a customized product, because it's based on technology and product present on market, and it can offer a high quality because it is a prefabricated module facade. And we can say that we have fulfilled all the objective that the RenoZEB had. Thank you for your attention. If you have any question, I will be more than happy to reply. And thank you.
Thank you very much, Laura. First of all, congratulations for the end of the project. I can see that you are pretty satisfied with all the results of the tests that you have performed. For sure, really plug and play solution. I saw it from the picture, so congratulations for that as well. Just one question from my side. Maybe I will ask over here to the audience as well, if they have any. But when do you think it will be ready for the market? Do you need some more testing, I guess, and some like to install it in other use cases? But can you tell me, like, if in 1, 2, 5 years it will be ready or not?
We are really satisfied about the result. As I said, we wanted to reach a TRL 7, but we can say that the prototype, I mean, the product it could be already ready for the market. We have already tested. We have 2 demo cases already tested in a real environment. Some implementation can be done in terms of thickness, because it's a quite thick solution. So some solution can be reduced in terms of millimeters, but let's say that it could be ready for the market in 6 months.
Well, okay, so congratulations. This is a good example of a European project that finishes well, I will say.
Thank you.
So, thank you, Laura. I will let Pedro come to stage as a last presenter. And if you have your USB, yes, I will put it over here. Wow, nice one.
In wood.
In wood, yeah. Pretty sustainable, this one. Voilà. Hai un problema con esta unidad? Wait.
Try to... Let's go.
Yeah.
Go, continue.
Okay.
Sacramento.
Sacramento. Okay. I was doing the wrong one. Okay, wait a second. Okay. Let me share the screens only. And
So,
here you are.
Okay, I will not be showing a project, a European project. I'm just going to show an example, a case of intervention I did for. Okay, thank you very much. For a former president's office. So this one should work something.
Fine.
Yes.
If not with that. No.
Okay. The mouse.
Up. Okay. So just click
the mouse. Okay. So the interventions, of course, started to assess the significance of the building, to understand how it moved in history, how it was forming, and this came out to be important for the project in the end, because on the right slide you see that there's a cloister and then a courtyard. The cloister where the nuns used to pray, and the courtyard where all the goods were changed. And this cloister had this gate that over the years, in the beginning of the 20th century, you see that the second courtyard disappeared, and in the pictures of 1940, this courtyard was lost. But this is going to be useful for the project. The former president's office is going to take only that piece of the convent, that is that entire piece, but we are only using that part. We found a picture of 1940 of the cloister, and this is important because we see there are some medallions on the arcs, and we see the handrails of the first floor that we are going to use afterwards. When I arrived there, this was like this, the cloister very, very destroyed. The floors were in cement screed and it were unrecoverable. There was some holes from past digging for archaeological diggings, and there were some tile panels in a very poor state of conservation, with a lot of salt and a lot of lost tiles, and this was the appearance. On the first floor, all the openings were closed with windows and with chicken nets. As you can see, it was transformed into storage room, but in the ground, outside the place where the courtyard existed, there were some scars in the ground, and so they were useful for the project. You can see on the left, on the right side, there's a column, and we found the other column that was lying down in the backyard, and it's going to be important. The interior was like this, with it was transformed into a storeroom. There was a lot of moisture, a lot of rotten woods, some stucco was falling down, and this was the appearance. Well, and now not this. No, okay. So the project itself was here. In architecture, there are some yellow is what you are going to demolish, in red what you are going to add, and in black what exists and what stays. This was something created by Viollet-le-Duc in the 18th century, and we still use it. It was a very good idea. You can see there that the major walls are kept, but the major intervention happens on the upper part, where the structure was weaker and was more rubbish, more destroyed. The first floor the same, the staircase and the elevator, of course, they show up in both levels. One of the ideas of the project was to create again this courtyard of the entrance, because this is going to be a former president, and we wanted to create an area for him to get out of the car and go inside and be with the comfort of being covered by walls. And so the idea was to make let's say not the walls, because they were lost, but to recreate the space with the green area. And so during these are pictures of the execution. You can see that we created a lot of infrastructures in the ground, created the boxes for the green places. We went to get the column that is on the right side. The courtyard was created with the plants, and in the end it stayed like this, with this light gate that disappears inside the bushes, but creates a space, a nice area to get in and get out of the car. All the tile panels were the ones that were lost were made replicas, of course, copies, but we fulfilled the pieces with lime, and then it was painted with temperas and colors to gain an integration of the forms and colors. In the center, we had some palm trees, 4 palm trees that were attacked by the bug that eats the palm trees. It happened all over Europe, in the south of Europe at least, and a new pavement was added to the place. In the upper floor, we removed the windows and designed again the handrails on the right side, based on that picture of 1940 that we saw, and we added the medallions on the arches, because they were lost and they were important for the drawing of the cloister. And here you can see that the pavement, here on the top there are some here, and on the top there are some stone boxes to hide the lights that we are going to see, and all these were made with the same stone. Because all the additions were made with the same stone. Here on the left, we see an handrail that was there and one that was redone, and this one was the one that was there, and the new one was redone with a very formal essentialization. It was with simple forms, but when you are far, it looks the same, but one is the existent and one is the new one. And so in the end, the cloister became like this. And so let's say we recreated the form of one of the 7 Serlio Treaty cloisters that there is in Portugal. And it was damaged in its form, and it became again how it was. And the light to have night ceremonies and gatherings, when it's needed. This is the intervention on the area where it was more damaged, and where the new staircase came in iron and then covered by wood. This is like a kitchenette for light meals and things, just some drawings. This was on the ground. We had to make a reinforcement of the pavement because it was going down, and because this was a huge room and we didn't want to cut the ceilings, the divisions were made with just furniture that you can see here on this picture, and this furniture are shelves. It's with 50 centimeters. You go in and you pack things and you come out, because it's just the space for go there and come out. Again, on the upper floor, the same. It was just needed to reinforce this in order to put that furniture there that divides the area of working for the former president for the meeting room on the other side. And one interesting thing is here on the bottom is that because we are just making an intervention on one piece of the convent, we needed to have thermal comfort and acoustic comfort. And so we added a new layer, a new window on the inside, and we left the windows like they were on the outside. And so this is the final result before the things to come in, with some pieces of furniture, and in the end just the logo to add. That's it. Thank you.
Thank you, Pedro. Very nice work. I really liked all the pictures, also because you reused some of the things that were already there, so that you try to clean them. And I mean, it's unfortunate for the palm trees that they had to be cut, but yeah,
they were lost because of the bugs.
Yeah, I can understand.
Yes, they have no solution. When they are going to die. We have a lot of examples that people tried to save them with a lot of medicines, and in the end, after 1 year of treatments, they die, and that's it. The same. So it's
it was useless. Yeah, I will give you this. Yes. Where is it? Where is it located? In Lisbon?
Yes.
In Lisbon. Okay.
Yes.
Well, good. Okay. Okay, next time let's hope that I will be able to go there. Okay, so thank you very much to all the speakers. We are 5 minutes late, but they were very nice presentations. So I will thank all of you. You were a bit unlucky that it was a bit late and not a lot of participation, but I mean, at least I enjoyed. So thank you for that, and see you next time. Thank you very much. Bye bye.
Thank you. Bye. Bye. Bye.
Ciao Laura. Bye bye.